So today, I'm going to talk with you about how we launch OpenSearch. You may all think that it's just /OpenSearch, but yeah, what actually happens when you do that? So, like any Java application, you've got a public static void main, and this is the entry point for OpenSearch. It's in a class called OpenSearch. Specifically, it's in the org.opensearch.bootstrap package. So here's our public static void main. It has to first disable the security manager, well, or setting the security manager to allow everything, and then later on it's going to tap it down. But the important thing is it creates this OpenSearch Bootstrap instance and then goes to this main, which in turn calls main on the OpenSearch instance, which then registers the shutdown hook, which will output stuff to the terminal, and then calls main without error handling. Main without error handling then calls notice that we've now gone to the command class because OpenSearch extends command. Specifically, OpenSearch extends environment aware command. So we go to the execute method. Well, that's not defined command, but as I said, OpenSearch extends environment aware command. So we get to this execute, which then, okay, it sets some system properties, etc., and then calls another execute method, where this execute method, if I recall correctly, is defined in the OpenSearch class itself. So now we're getting into the specifics of executing OpenSearch. So it'll set the PID file so we can keep track of the PID, the process ID. But then down here calls this init method. The init method calls bootstrap.init as a static. So now we're getting into like we're going to actually start reading settings, things like that. So secure settings are loaded on startup. So that's a very important thing. That if you have any settings stored in the OpenSearch key store, they get loaded once on startup, and then never again. This is, I believe, to like minimize access to the key store. Then the next interesting thing, it checks to make sure that nobody's tried to mess with the Lucene jars. It's actually not that smart. It's basically just trying to make sure that you didn't do an in-place upgrade of Lucene. You can go check this out. It's just checking like, oh, is the current OpenSearch version's Lucene version the same as Lucene's Lucene version? So yeah, again, not that smart, but it's a thing that it does. Oh, I forgot to mention that up here. So this is a static method, but we create an instance of the Bootstrap class. So this is a singleton. It's basically like sort of our global variable that until we shut down will be kind of the process, more or less. And then where things get interesting is actually down here in instance.setup, which is actually called bootstrap.setup. Where is it? Down here a little bit. This bootstrap.setup is where we call the constructor for node. Now, some of you, if you've ever had to add a new service to OpenSearch, add a new API to OpenSearch, you may be familiar with the node constructor. Not this constructor, but the real constructor. So this is, as you can see, the declaration of the constructor starts on line 421. I'm just going to temporarily collapse the body of the node constructor. As you can see, it goes down to line 1360. So it's almost 900 lines. This constructor is a monstrosity. This is where everything in OpenSearch, almost everything, gets created. This is where everything that you think of as a node gets created in this constructor. We talk about, well, some of us have ranted a bit about OpenSearch's very monolithic architecture, that it's like one big ball of wax. This is the hub. Like everything sort of extends out of this constructor. So yeah, pretty much everything going on in the OpenSearch process is created here. It's terrible. Like pretty much every software engineering piece of advice that you get about layering things don't have one, kind of God object that controls everything. Nope. This is the big God object that controls everything. Yeah, it's terrible. But that's what it is. So a lot of this constructor, like the first couple hundred lines, are largely around loading plugins. So it's sort of going through and doing the plugin discovery mechanism. What I wanted to cover though was more focused on like, okay, so we're starting up the node, everything's getting constructed. As I said, there's a lot of stuff getting constructed here. A lot of it comes down to things whose name end in plugin, module, and service. So the general rule that I've been able to kind of extrapolate out, a module has sort of specific business logic that is driven by plugins. We're going to dive into network module as like a specific example. And then the services tend to be more, things that do stuff. Network service has some helpers that, do DNS lookups, things like that. Search service takes care of routing, like handling some of the logic of executing a search. Indices service is the service that keeps track of what indices you have. And for each index, it has an index service. And so then that's how you're able to say, like, okay, I have to do something with an index with this name. Call indices service to figure out which index that is. And based on that, get the corresponding index service. And then from the index service, you can get things like, I believe, index settings. I believe you can get the mappings that way. You can also ask, I believe you can also ask the index service. There is a shard service. I'm trying to remember if index service holds a reference to the shard service to know what are the shards for the index and where are they. But anyway, as I said, we're going to mostly focus on the network module with the network plugins. Network service actually isn't that exciting, but as we kind of scroll through here, so you see analysis module. This one loads all of the analysis plugins that know how to do text tokenization. Yeah, somewhere in here, there's a discovery module, which takes care of node discovery. And that discovery module is quite important during startup, right? If the node is the cluster manager or is eligible to be the cluster manager, it will discover any other cluster managers and they'll have a little election. And then if a node is configured to start as a data node, then it'll be like, oh, yeah, I need to go through the discovery module to know how to discover the cluster manager. And so, yeah, that how that works will vary. Cluster module, it holds a reference to the cluster service. Actually, cluster service is an interesting one, if I recall correctly, because this is the thing where you can like add a cluster state listener if you want to listen for updates to the cluster. Oh, incidentally, something that would be a fun project for some definition of fun would be to go through this node constructor and create a dependency graph. Like figure out which things, which of these modules, services, well, yeah, mostly modules and services, hold references to other modules and services, right? Because this gets very, very complicated. And I'm pretty sure we would find that overall, the OpenSearch node is very highly interconnected, which again, not great from a software engineering standpoint. And you can see how it would be very challenging for us to decompose OpenSearch into a series of microservices. We can try, but I want to get down to line 900 something. I've got a little cheat sheet that, oh, here's indices service. So you can see the indices service needs references to a lot of stuff, right? So yes, ingest service is a much simpler one. It only needs, a few. Metadata create index service. Down, scrolling down. We're going to talk about action module in a little bit. Action module is actually pretty exciting. But before we get to action module, I want to get to network module. So the network module, as I said, it's the thing responsible for how networking is implemented. OpenSearch, it's worth noting, has like two main networking implementations. There's the HTTP networking that, when you make a REST request to the OpenSearch cluster, that request will land on a node, and it'll be handled by an HTTP transport that knows how to speak HTTP. But then the node-to-node communication is all just straight TCP based. Like, it's not via HTTP. Yeah, it's a binary TCP based protocol. So this is where you've got the HTTP transport and then just what's called transport. When you see transport, it means TCP. Yeah, HTTP or REST, then it's the HTTP transport for talking to people outside the cluster. So, but the network module is what gives you both of those things. In terms of how it actually does it, actually implementing the sockets and stuff, that's pluggable. There are network plugins that provide different transports. So, yeah, down here, again, we're still in that node constructor where everything gets created. So this transport here, this is the thing that creates the transport for node-to-node communication. So we ask the network module, hey, based on the plugins you've loaded and settings that were configured, what is the transport? Based on that transport, we pass into a transport service. So this transport service gets passed into a bunch of other services for node-to-node communication. If I recall correctly, transport service is passed into, I'm trying to remember where search service is. Oh, like snapshot service, right? Like when you issue a snapshot request, that has to go and talk to a bunch of the nodes to say, like, hey, you upload your shards as part of this snapshot. So yeah, that requires the node-to-node communication. Same thing for restoring. Actually, for some reason, restore doesn't take the transport that. Oh, maybe it's the repository service. That's odd. I need to look into the restore service and figure out how that works. But yeah, getting back to network module. Sorry, I'm going to check my cheat sheet. Right, I went too far. So when we create the network module, one of the things that it's given is this REST controller here. So I wanted to get into how does OpenSearch understand how to process REST requests. So we've gotten into starting up, it's allocating all of these services, all of these modules. A lot of it's provided through plugins. How do we actually understand a REST request? How does that work? We call this network module constructor. That REST controller is actually an implementation of HTTP server transport.dispatcher. We passed in the network service, and the thing right after that was the REST controller. So network service, and so here's our dispatcher. REST controller, dispatcher, same thing. And so on startup, the network module iterates through all the network plugins. For the HTTP transports, we're going to have HTTP transport factories. And these HTTP transport factories are going to hold on to a reference to that dispatcher. And what happens later, there's a call from that node constructor, the node constructor HTTP transport call, which is, again, still in the node constructor. Yeah, this, in my opinion, we should move this. The fact that this line 975 creates the HTTP server transport, but then doesn't like use it right away, I feel like this thing should be moved down closer to where it's first used. I don't really like the fact that line 975 is just like, hey, here's the HTTP server transport, and then it doesn't actually get used for another 50 lines. I think that to me feels wrong. We should move this. But when we create the HTTP server transport, this is where, based on the HTTP type setting, this is where we decide which of these factories that we got from the plugins should we use for our HTTP server transport. By default, we end up using NetE4, if I recall correctly. So specifically, we use the NetE4 HTTP server transport. This is the thing that's built on top of Netty. Netty's implementing the async request response streams. It's able to handle, well, actually, most of the HTTP stuff is defined here in abstract HTTP server transport. So we've registered this thing. There is somewhere a call to bind server. So this is what's gonna, yeah. So when we create the Netty for HTTP server transport, which is in its do start. So do start incidentally was called by see, this is, yeah. Well, shoot. Where do we actually start? Where do we actually start the HTTP server transport? Was it? No. So here we just created it. This is the factory that returns the thing. Where do we actually start this thing? So we bind it. We pass it to node service. Does this guy start it? I don't know who actually starts the HTTP server transport. Who starts it? I don't know. I should figure this out. Because this thing's closable, but ultimately it just closes the indices of this. Yeah. So if somebody can figure it out, who actually starts the HTTP server transport, that'd be great.
Go to node Java line 1504.
1504?
Yeah. It pulls it out of the dependency injector and calls start.
Ah.
Or 1501.
Yes. Okay. Yeah. So okay. Cool. Yeah. Because I was like, wait, where's the HTTP? This is the only reference to HTTP server transport. So it's added into the dependency injector and then pulled right back out. Now, this isn't the node constructor, right? We've left the node constructor, so this is in node.start. Later on, the node constructor puts everything in place, and then the start method is what actually starts it, so that it's actually going to do stuff. Cool, thank you. But yeah, at this point, it no longer has it as a variable. It has to fish it out of the injector. And so when it starts up, that's where it gets bound to port 9200, and that's where it's listening, et cetera, et cetera. The abstract HTTP server transport. So the HTTP server transport interface, well, okay, it has a nested dispatcher, has the dispatch request. Now, the dispatch request, the dispatcher is actually the REST controller. What I wanted to see was, how does this thing make use of its dispatcher? Because that's the thing that's going to map from an HTTP request to the REST controller. Because remember, this dispatcher is the REST controller. Yes. So in this dispatch request, which is package private, this dispatch request is called by handle incoming request, which is called by, we have a Netty for HTTP request handler, right? And this server transport is our Netty for HTTP server transport. So yeah, this is the thing. This Netty channel read 0, if you've worked with Netty, this is how it's all these channels, right? And so you're listening on a channel, and based on that, yeah, it triggers this, which calls the incoming request, which calls handle incoming request, which down at the bottom calls dispatch request, which ends up delegating down here to the dispatcher. So this is how we get from Netty listening on a port through to the REST controller. Now, the REST controller, how does it know how to handle this request? Well, let's go to REST controller, and it's dispatch request. So it's this dispatch request. So it goes through this try all handlers. So it's got a REST request and does this try all handlers further down, which does a get all handlers based on the request params and the path to the request, we've got this funny path try of so-called method handlers. This is the thing that has the logic to, based on the request path, it's going to find a matching handler somewhere. Now, how does this path try get constructed? Well, the path try is built by these calls to register handler no route, which, well, basically is right here. Right? It gets called here. And then this, it gets called. So here's register with deprecated handler. There's another call to register handler. So this one? Or am I going to the same spot again? No, I'm basically going to the same spot. Ah, yes. Okay. So this register handler, the public register handler, this is the one where if we have something that knows how to handle, well, so we end up binding these things that know how to handle REST requests that look a certain way. And this is what's going to go into the REST controller. And this is ultimately what's going to connect, again, from that Netty socket through the HTTP transport into this thing. And then this thing's going to dispatch out to the code that knows how to handle a specific REST request. So this gets called by action module. So if you ever want to know how the OpenSearch APIs are defined, and if you want to get the full list of OpenSearch APIs, this is them. Init REST handlers in action module. Each of these, so you've got all these REST whatever actions. So let's see index put alias, right? So these are all of the different routes that you can do to do an index put alias request. It can be slash index name, slash underscore alias, slash name, etc. Yeah, all these different forms. Yeah, this is actually a more exciting one. I didn't expect to have one bound to so many routes. Well, all these routes go into that path try structure, and they're within that path try iterator thing. There are rules for what takes priority, and it'll go through and try to match the path, taking into account the HTTP method as well, and it'll go through and figure out like which path matches, and then dispatch to the relevant REST action, the relevant REST handler implementation. So suppose a request did come in that looked like one of these. Well, base REST handler has a handle request where, as you can see, one of the first things it does is it calls prepare request. Actually, with a lot of these, the prepare request is really where all the exciting stuff happens. So in this case, with index put alias action, it ends up calling a node client, calling the admin client, and then uses the aliases API. So essentially what it's doing is this thing has gotten the HTTP REST request, and it's now going to map that to an internal transport request. When you see client like this, it's the transport client, that TCP client for node-to-node communication. This one's actually pretty simple. In the prepare request, it just says, I'm going to delegate this out to the transport client to handle it directly. And then, just to kind of complete the picture, who calls the init REST handlers? Well, init REST handlers is, of course, called from node. Down here, yes, this is right at the end of the node constructor. This is where we actually bind all the REST paths to the corresponding actions. I think that's pretty much what I wanted to cover. Like, so we started with starting up the OpenSearch process from the public static void main. We went through that bootstrapping code, got eventually to the node constructor. We spent almost all of our time in that node constructor, where so many services, so many modules get created. The network module via the NetE plugin sets up the NetE for HTTP transport. When that network module was created, the node constructor gave it the instance of action module. No, sorry, not the action module itself. It asked the action module for its REST controller. And then that REST controller was bound to the HTTP server transport. Down here later in that constructor was where the REST controller actually gets populated with all of the handlers. At the time that is bound to the HTTP server transport, it doesn't actually know how to do anything yet, but then later on, it will know how to do everything. So I hope that demystifies some of how OpenSearch is able to handle HTTP requests. Questions? Comments?
Thanks, Froh. I think this is helpful. Do you also want to touch upon the plugin interaction, or it could be a very separate topic altogether? Basically, registration and the registration of handlers.
Yes, actually, so it's actually relatively simple, if I recall correctly. So a lot of it is done through plugin service, right? So plugin service is created. It's one of the things created relatively early on in the node constructor. So here, node constructor starts at line 421. Plugin service is created down at line 479, right? So only 50 lines in. So yeah, plugin service is, I remember going through this at some point. Yeah, okay, so already we've got the plugin, we've already discovered the plugin classes. Let's see how that happens. So the class path plugins were populated where? Oh, okay, yeah, this happens before we even get to the node constructor. So the constructor that gets involved from Bootstrap passes in an empty list. So we get into the plugin service. Class path plugins is an empty list. So this for loop doesn't actually do anything. We must have to. Okay, yeah, so this is where, yes. Yeah, so we don't actually have any plugins passed in via the class path. I wonder if we can just scrap that code. It feels like something where it's maybe, well, yeah, mock node might do something. Yeah, it might be for testing anyway. But yeah, so the module bundles, I believe. So this is everything. I believe this is where we load the stuff that's under /modules, right? So this is where we have, you know, analysis common, ingest common, lang painless, some of that kind of core functionality. Reindex is actually implemented through a module. We got all these bundles associated with those modules. So these are plugins, but more like built-in plugins. And now we find things that are under /plugin or yeah, plugins /. But yeah, this collection of bundles. So this is where it's essentially just like walking the plugin directory and sort of so read plugin bundles. And yeah, so this is where you've got your plugin properties. This is where yeah, it loads the info, and then you've got a bundle based on that info and the path. Loads jars, well, finds jars, right? And then the actual loading of bundles. So this will be where we've got the class loader. So we create class loaders based on the set of jars that we discovered. We've created a class loader. The class loader is making use of the bundle URLs. So the bundle URLs are pointing to the jars in the bundle where bundle meets plugin. Yeah, so this class loader is extending the OpenSearch class loader, adding in these additional jars. And then we have the plugin class name, which you got from that plugin info properties.
Right.
And then based on that, it's going to load the plugin class. So yeah, that's pretty much it. Yeah, and the load plugin class is just use reflection to say, okay, load that class from the class path. And then with the plugin class, we're going to call load plugin, which, yeah, so this plugin class may have constructors where, yes, actually we must have exactly one constructor. If there are 0 constructors, we throw an exception. If there's more than one constructor, we throw an exception. And then there's a little bit here, what parameters you can use, right? So a plugin constructor can have 0, 1, or 2 parameters. A no-args constructor, so it's just creates plugin, a constructor that accepts settings, or a constructor that accepts settings and a config path. So those are your 3 options. Yeah.
Perfect.
And
Thanks, Froh.
the basic plugin interface is very simple. Like it's really more about this construction. In terms of actually doing something with those plugin instances, that's the responsibility of the individual modules, right? So plugin service loads all the plugins. Network module says, hey, plugin service, give me all of the network plugins. And network module knows how to talk to network plugins to get, for example, an HTTP server transport. And it's important to note that the plugins get created on startup, and that's basically like the only time when you can actually deal with secure settings. So we have this plugin that is able to make a call to AWS Personalize to re-rank search results. One of the things that you may want to configure is your credentials to call Personalize, right? And so you're not going to just put your AWS access key and secret key in plain text somewhere, right? So you write it into the key store as a secure setting. You can get these secure strings. But it's important to note that you're only allowed to do this on startup. There's actually a spot. So we're in that bootstrap.it. Yeah, so here's where we have the secure settings. We load the secure settings. Yeah, I'm trying to remember where that happens. But yeah, there is, so key store, okay. Create environment, IOUtils.close key store. So we do this pretty much right after that instance.setup. So remember, instance.setup was the thing that created the node, which then creates the plugin service, which loads all the plugins, right? And creates the components from the plugins. And so after the node is created, but not started, we close the key store. We say, nope, okay, all access secure settings are done. So as an example of something that uses the secure settings, AWS credentials can be stored in the secure settings. And if you do make use of secure settings, you must make use of them on startup.
Right. Perfect. Makes sense. Thanks.
Mm-hmm. Hope that helped.
Can I climb on my soapbox and complain about something?
Oh, absolutely.
We
Please.
have a little bit of time.
Yeah.
Go back to the constructor for node.java. And this kills me. So this constructor is like literally 1,000 lines long.
Yes. Yeah. And just under 900.
Okay.
Just under 900. But yes.
I'm rounding up.
Yeah. Yes.
Just having this amount of single bit of code is kind of problematic, but it's extra problematic putting it in a constructor.
Yeah.
And the reason being because like inside a constructor, you essentially have a partially constructed object, right? This pointer of the object. And like, as an example, you can have like final fields of that class that are as yet uninitialized. And so there's just like a lot of opportunity here to like leak a reference to this node.java instance out of this constructor. And then like, for example, let's say you somehow passed a reference to this instance, and then something in here threw an exception, and you actually never completed initializing this instance, but then something else still has a reference to it. That thing is just like forever holding on to a reference to a partially constructed object. And all sorts of guarantees that the language is supposed to give you just don't hold anymore, because all that's to say, the better sort of mechanical restructuring of this, ultimately you would hope you could break this up into not having just 1,000 lines of code. But the better sort of Java way to do this would be to move all this code into a public static method and then change the node constructor to do nothing but take the fields and do
Mhm.
field assignment, and then
Yep.
make the constructor private. Inside the static method, you haven't even created your node instance when you're doing all the setup work. And then once you've completed the setup work and you have all the fields that you want to pass to the node instance, you construct a node instance and return it.
Right.
But this pattern of doing complex logic inside a constructor is all over this code base. It kills me.
Incidentally, so I mentioned when I first got to the node constructor that a wonderful exercise for someone to undertake if they're so inclined. A person could go through and sort of map each of these constructors and say, like, for example, identity service. Okay, identity service is actually a pretty simple one, that it depends on the settings, right, that we got near the beginning. And identity plugins, fine. But with a bunch of these, like a bunch of these services depend on other services, right? Of course, as soon as I say that, I'm not seeing any. Cluster module, right, depends on cluster service. Okay, it has the set of cluster plugins. Depends on cluster info service and snapshots info service, right? What is the dependency between all of these services? If we wanted to break this down, are there potentially disconnected subgraphs that we could initialize separately? I don't know. Could we break this thing up? In addition to doing as Andrew said, move this logic out of a constructor into even a static initializer, could we then kind of break it up? I suspect that there's quite a lot of interconnection that we can't easily detangle. But even if we could start to split it up, I think that would be great. Because it also bugs me that we keep making this bigger, right? Because yes, it's 900 lines now, but I know that I've added to this constructor. Others have too. So yeah,
I mean, there's a reason why it's so big is because everybody keeps going back here because this is like the path where stuff gets initialized.
Yes, yeah. Well, yeah.
And it's inside a constructor.
I don't know if there's something we can do to split it up or not. Yeah, I don't know. Anyway, so thank you all. See you next time.